Hi, this is from Dr.B.Vijayakumar, HOD of Physics, SNS College of Engineering. Today we discuss another one topic of Young's modulus, non-uniform bending, theory and experimental. This is also is form of elasticity or properties of matter. So the Young's modulus is a comprehensive analysis of non-uniform bending. So the bending stress in a beam is formed in exactly middle of the beam. The load is applied in the middle of the beam. The bending is created in exactly middle. So this presentation explores the concept of Young's modulus and its determination through non-uniform bending. We will delve into the theoretical foundation, experimental methodology, and application of the important material properties. Theoretical foundation of non-uniform bending. When a beam is suspended to a load that is not evenly distributed across its length, in such cases, the bending moment and the curvature vary along the beam. The theoretical framework for this phenomena relies on this principle of superposition, which allows the calculation of the deflection and stress due to the multiple loads applied to a beam. Differential equations. A mathematical basis of non-uniform bending analyze relies on a set of differential equations that related the bending moment, curvature, and deflection of the beam. This equation can be derived from the principle of elasticity and the equilibrium. Moment of inertia, which represent the resistance of the beam to bending, play a crucial role in determining the deflection and stress due to non-uniform bending. This property is dependent on the cross-sectional shape and dimension of the beam. Boundary condition, which specify the constraint and the support applied to the beam, are essential for obtaining unique solution to the differential equation governing non-uniform bending. This condition dictate the deflection and stress distribution along the beam. So the experimental setup and methodology. The experimental setup involves a cantilever beam which is fixed at one end and free end at the other end. A known load is applied to the free end, causing a beam to deflect. This deflection measured at various points along the beam using a precise instruments such as a dial gauge or a strain gauge. The curvature of the beam can be determined by measuring the slope of the deflection curve at a different point along the beam. Cantilever beam. A cantilever is fixed at one end and free at the other, making it suitable for studying non-uniform bending. Load application. A known load is applied at the free end of the cantilever beam, causing it to be deflect. Deflection measurement. The deflection of the beam is measured at various points along its length using a precise instruments. The measurement of deflection and curvature. The deflection of the beam is measured using a dial gauge, and the deflection measured using a dial gauge, and curvature calculated from the deflection data. The calculation of non-uniform bending by using a Young's modulus method. The bending moment, it's measured the internal force acting on the beam due to the applied load. Curvature of the beam is measured of the degree of bending. Moment of inertia represent the resistance of the beam of bending. Young's modulus material property that describe the stiffness of the material. Then comparison of theoretical and experimental result. The theoretical predictions, mathematical model and principle of elasticity. The theoretical deflection of the beam can be calculated. The experimental result obtained from the deflection measurement provide a real-world data of the beam behavior. In comparison, the theoretical prediction with the experimental result along with for an assessment of accuracy and validity of the theoretical models. So the factor affecting the accuracy of Young's modulus determination, the measurement of error, the material properties and assumptions. So these are the application of non-uniform bending analysis, the bridge design and building construction, aircraft designs. So this is all the reference. I prepared the PPT to form of Young's modulus non-uniform bending theory and experimental. Thank you very much. We discussed in another one video in another one topic. Thank you.